Hello students, in the previous lecture video, we have already discussed about the detailed estimate of RCC slab culvert. In today's lecture video, we will discuss about the detailed estimate of Hume pipe culvert. I am Soumya Sahu, lecturer in Civil Engineering at SKT Government Polytechnic, Rourkela, and this video lecture is prepared for the 5th semester Diploma Civil Engineering students. Students, pipe culverts are generally provided when the discharge of the nala or the stream is very small, and in no case it is assured that the diameter of pipe should be less than 30 cm. If in any case the diameter of pipe is less than 30 cm, then the pipe is likely to get choked, and it is usually preferred to provide a splayed wing wall for the ease of approach of water. Before going into the detailed estimate part, first I would like to discuss the parts of Hume pipe culvert. So see, I have shared a slide which is showing a pipe culvert. Here you can see only one number of pipe. In this slide, you can see there are 4 number of pipe. So the number of pipes to be provided depends upon the amount of discharge. Here I have shown another picture of pipe culvert having 3 number of pipes. And this portion is known as face wall. Face walls are provided on either side of pipe culvert to hold the pipes in position, and these are the wing walls. This is the pipe. So now students, let's see the plan and sectional elevation of pipe culvert. Students, this is the face wall. This is the wing wall, and this is known as the turn wall. As you can see the plan, there are 2 number of face walls, one right here and another one right here, and total 4 number of wing walls. Here a wing wall, this is number 2 wing wall, number 3 wing wall, and number 4 wing wall, and 4 number of turn walls. Number 1 turn wall, number 2, 3, and 4. The width of the face wall from this point to this point, it is given as 50 cm, and an offset is provided on either side. This side there is an offset, and this side there is another offset. So in order to find out the width of the offset, let's see the turn wall portion. In the turn wall portion here, you can see the total width is given as 70 cm from this point to this point. And if you see the longitudinal section, it is clearly mentioned that this width, it is 40 cm, and above it the turn wall is having a width of 30 cm. So now again look at this portion. So the total width is 70 cm, and from this point to this point the width is 40 cm. So if we subtract 70 minus 40, we will get 30 cm, and this 30 cm of offset is provided on both the side, this side and this side. So if we divide 30 by 2, then we will get 15 cm. So the width of the offset is 15 cm. Now let's see. Here the width of face wall is given 50 cm from this point to this point, and both sides the width of the offset is 15 cm. So if we add 50 plus 15 plus 15, we will get 80 cm. So 80 cm is the total width of the trench where the excavation work is to be carried out. Okay. And if you see the half sectional elevation on ABCD, here you can see 3 number of pipes having internal diameter 60 cm and external diameter as 70 cm. And you can see here the stone pitching is provided. This below the pipe here, this is the stone pitching provided to prevent erosion. And here you can see the curved line is provided here. The road line is given here. This is the ground level. And on the left hand side, you can see the cross section of wing wall. So the wing wall is having a portion with 50 centimeter breadth. Above it, we are having the portion of wing wall having 40 centimeter breadth, and above that, the breadth of the wing wall is 30 centimeter. Here I have shown the three-dimensional view of Hume pipe culvert. Here you can see this is the face wall. Face walls are provided to hold the pipes in position. This is the upstream side, this is the downstream side. These are the splayed wing walls, number 1, number 2, 3 and 4 number wing walls. These are the turn walls provided over here, and this side also there are 2 number of turn walls. The total 4 number of turn walls are provided, and this is the pipe. Here I have shown another three-dimensional view of Hume pipe culvert. Here I have shown only 1 number of pipe. This is the face wall, this is the turn wall, this is the stone pitching provided below the pipe, this is the pipe, and these are the wing wall. So the construction of Hume pipe culvert follows a sequence of work, and that sequence is first earthwork in excavation, then cement concrete work. After that, first class brick work is to be done. After that, pointing work is done, followed by fixation of pipe. So this is the construction methodology of Hume pipe culvert. So with this background knowledge, let's quickly start the detailed estimate of Hume pipe culvert. So for the detailed estimation of a Hume pipe culvert, you have to draw a table showing the details of measurement and the calculation of quantities. In the table, you have to mention the item number, the particulars of items, number of items, length in meter, width in meter, height or depth in meter, and then quantity, and then explanatory notes. Okay. So first work is earthwork in excavation. So let's see where the excavation work is to be done. If you see the plan, the excavation work is to be done first in the face wall region, then in the wing wall region, in the turn wall region, and also excavation work is to be done for this triangular portion of wing wall. The excavation work is also to be done for the stone pitching which is provided below the pipe. Okay, so let's first see the earthwork in excavation for the face wall. So there are 2 number of face walls, one here, another one here. Let's see what's its length for excavation. So the excavation work is to be carried out from this point to this point. So if you see the half sectional elevation on ABCD, this length is 3.1 meter. Here it is mentioned. This length is from this point to this point, and this length is 3.1 meter. Then, what is its breadth? Its breadth from this point to this point is 50 centimeter, and the offset on either side is of 15 centimeter. This is 15 centimeter. So if we add 50 plus 15 plus 15, we are going to get 80 centimeter or 0.8 meter. And what is its depth? If you see the half sectional elevation on ABCD, the excavation work is to be done below the ground level. So this is the ground level, below which the depth is here. It is 50 centimeter and 30 centimeter. So 50 plus 30 is equals to 80 centimeter or 0.8 meter. So in 0.8 meter, the excavation work is to be done. So the number of face wall is 2, length is 3.1 meter, width is 0.8 meter, height is 0.8 meter, and the quantity I have already calculated. It is 3.97 cubic meter. So next excavation work is to be done in the wing walls inclined portion. See, there are 4 number of wing walls, 1, 2, 3 and 4. So what is its length? So the length will be 2.3 plus 1.8 divided by 2. Similarly, here you can see the breadth on one side of wing wall is 80 cm, whereas the breadth on the other side is 70 cm. Okay. So here also we have to take the average breadth. So 0.8 plus 0.7 divided by 2. And what is the depth for which the excavation work is to be done? The excavation work is to be done from this point to this point, below the ground level. This distance is 50 cm and this distance is 30 cm. The total depth of excavation is 80 cm or 0.8 meter. So let's quickly fill the table. So the number of wing walls are 4. The length, we have to take the average length, 2.3 plus 1.8 divided by 2. We have to take the average breadth here, so 0.8 plus 0.7 divided by 2. And the depth of excavation for wing wall is 0.8 meter. So I have already calculated the quantity as 4.92 cubic meter. Then next excavation work is to be done in the wing wall's triangular corner. So there are 4 number of triangular corners. One is present right over here, this is. Another one is present here, another one is present here, another one is present here. So there are total 4 number of triangular corners of wing walls. And you can see this breadth here is 60 centimeter, it is given. And this total breadth of the trench from this point to this point, it is 80 centimeter. As we have already calculated this point to this point, this breadth is 50 centimeter and offset on both sides it is 15 centimeter. So the total breadth of the trench is 80 centimeter. So we can easily calculate the area of this triangular portion as half into 0.6 into 0.8, isn't it? And what should be the depth of excavation? So excavation work is to be done below the ground level from this point to this point, and this total depth is 80 centimeter or 0.8 meter. So let's quickly fill the table. There are 4 number of wing walls, triangular corner. So half into 0.6 into 0.8 into the depth of excavation is 0.8 meter, and I have already calculated the quantity as 0.77 cubic meter. Then next excavation work is to be done in the turn wall area. So there are total 4 number of turn walls. If you see the plan, you can see 1, 2, 3 and 4 number of turn walls. And what is the length of this turn wall? See the plan. On one side the length is 95 centimeter and on the other side the length is 80 centimeter. So we have to take the average length. So here the length will be 0.95 plus 0.8 divided by 2. And what is its breadth? The breadth is already given here, 70 centimeter. And what is the depth of excavation? The depth for excavation should be taken below the ground level. So it should be from this point to this point. So this total depth is 0.8 meter. So let's quickly fill the table. 4 number of turn walls. Length is 0.95 plus 0.8 divided by 2. The breadth is 0.7 meter and the height is 0.8 meter. And I have already calculated this quantity as 1.96 cubic meter. Okay. Next, the excavation work is to be carried out for underpipe. So if you see the figure, the total length from this point to this point is given as 10 meter. But the excavation work for the underpipe is to be carried out from this portion to this portion. So here you can see this width is 40 centimeter and below that the footing width is 50 centimeter. So this projection is of 10 centimeter. So if we subtract 10 centimeter on both the sides from 10 meter, we will get the length for which excavation work is to be carried out for underpipe. So 10 minus 0.1 minus 0.1 equals to 9.8 meter is the length of excavation for underpipe. Then we have to find out the breadth. In order to find out the breadth, we have to see the half sectional elevation. See, from this point to this point, the excavation work for underpipe is to be carried out, and this width is 3.1 meter. And what is the depth? See, for design of pipe culvert, the depth of underpipe is calculated by a formula, and that formula is 0.25 d, where small d is the internal diameter of pipe. And in the given question, the internal diameter is already mentioned here as 60 centimeter or 0.6 meter. So the depth of excavation for underpipe will be 0.25 into 0.6, which will be equals to 0.15 meter. So I have already substituted the values here. There would be only one number of excavation work is to be carried out. So the length is 9.8 meter, breadth is 3.1 meter, and the depth is 0.15 meter. So 1 into 9.8 into 3.1 into 0.15 equals to 4.56 cubic meter. And the total quantity for earthwork in excavation is calculated by adding 3.97 plus 4.92 plus 0.77 plus 1.96 plus 4.56 cubic meter, which is equals to 16.18 cubic meter. The next work which is to be carried out is cement concrete work. See, if you are good at doing the quantity estimation part for the excavation work, then you will easily calculate the quantities required for cement concrete work. So for the face wall, there are two number of face walls, and the length of face wall is 3.1 meter. The width is 0.8 meter. We have already found out all these values, and the depth for which cement concrete work is to be done is from this portion to this portion, which is 30 centimeter, because only in this portion the cement concrete work is done. So that is why here in the table the number of face wall is entered as 2, length is entered as 3.1 meter, the breadth is 0.8 meter, and the depth is 0.3 meter, and the quantity is calculated as 2 into 3.1 into 0.8 into 0.3, which is equal to 1.49 cubic meter. Similarly, for wing wall, there are 4 number of wing walls, and the length is calculated by taking the average length of wing wall, because one side it is given as 2.3 meter and another side the length of wing wall is 1.8 meter. So we will take the average length of wing wall. So 2.3 plus 1.8 divided by 2, and the breadth will also be taken as the average breadth, because one side of wing wall the breadth is 0.8 meter and on the another side the breadth is 0.7 meter. So the breadth of the wing wall will be 0.8 plus 0.7 divided by 2, and the depth for which the cement concrete work is to be done is from here to here, which is 0.3 meter. So by putting all those values, the quantities are calculated as 1.85 cubic meter. Then next one is the wing wall inclined portion. Wing wall inclined portion is its triangular corner side, which is having a base of 60 centimeter and the width as 80 centimeter. So there are 4 number of triangular corners present, and if we multiply the area of these triangular corners along with its depth where the cement concrete work is to be done, which is 0.3 meter, then we will get the quantity. So here 4 multiplied with half into 0.6 into 0.8 into 0.3, which is equal to 0.29 cubic meter. Turn wall portion. So from the figure it is clear that there are 4 number of turn walls, and the length of turn wall is one side 95 centimeter and on the another side it is 80 centimeter. So we have to take the average length, and the width of turn wall is 0.7 meter. And what is the depth of turn wall for which cement concrete work is to be done? It is 0.3 meter. So the quantities are calculated. 4 multiplied with the average of 0.95 plus 0.8, and it is multiplied with the width 0.7 meter. It is multiplied with the depth 0.3 meter, which is equals to 0.74 cubic meter. Then cement concrete work is done in the under pipe and in between the pipe up to the half of the height. See, cement concrete work is done in the under pipe region from this portion to this portion, which is having a height of 0.15 meter. We have already calculated it from the formula 0.25 into internal diameter of pipe. And the cement concrete work is also done above the under pipe up to the half of the diameter of pipe. So this total height would be half of the diameter of pipe. So the external diameter is 70 centimeter. Half of this is 35 centimeter, and the depth of under pipe we have already calculated it as 15 centimeter. So 35 plus 15 is equals to 50 centimeter, and its width is 3.1 meter, and the length of excavation for under pipe we have already calculated it here as 9.8 meter. So this is for similarly for the case of cement concrete work also, the length would be 9.8 meter, width would be 3.1 meter, and the height will be 0.5 meter, as the depth of under pipe is 0.15 meter and half of the diameter of pipe is 0.35 meter. So if you add 0.35 with 0.15, then the total depth would be 0.5 meter. So the number is 1, length is 9.8 meter, width is 3.1 meter, and the depth is 0.5 meter, and the quantity is calculated as 15.19 cubic meter. Then next we have to deduct half of the pipes for cement concrete work, because as you can see the figure, in between this portion there is no cement concrete work. Okay, no cement concrete work has been done inside the pipe. So we have also considered this portion in our calculation, so we have to deduct for this portion. So there are 3 number of pipes, so the number of deductions will be 3. The total length is 9.8 meter, and the cement concrete work is done up to half of the diameter of pipe. So we have to take half of the area of the pipe. So half into 5 by 4 into 0.7 square, where 0.7 meter or 70 centimeter is the external diameter of the pipe. And this quantity is calculated as 5.66 cubic meter. So the net total quantity is calculated by subtracting 5.66 from 19.56 cubic meter, which is equals to 13.90 cubic meter. So students, in today's class we have discussed about the Hume pipe culvert, its different components, and we have in detail studied about the estimate of excavation of earthwork and cement concrete work for Hume pipe culvert. So thank you students. If you have got any doubts, you can ask.